Section 2.4 talks about parallel and perpendicular lines, and this is something that you'll see periodically. It's basically what we've done before, but just with one extra component. So what we want to do in the beginning, you can treat this kind of as a warm-up and pause the video, and then I can go over it with you. So as you're looking at this first one, it's saying, what's the slope of line A? So hopefully we found 2 points and we can find the slope between them, right? If you pay attention, you can go up 1, 2, 3, and then over 1, 2, 3, 4, 5. So it would be 3/5. Now you could have picked other points, but those were the two that I saw first. Then it says, what's the slope of line B? If you did the same process, you would have ended up with the same slope, 3/5. Then it asks, what's the slope of line C? So we would then look at the 2 points. I'm going to use these down to over 2 or down 1/1 the whole time, right? It's 2/2 negative, sorry, which really is -1. The exact same thing would have happened with D. You would have ended up with -1. Now, then it asks which lines are parallel. Hopefully we are familiar with parallel. A would be parallel to B, okay, or you could have just written A and B, which then also means C is parallel to D. Oh, C and D. What do you notice about these slopes of the parallel lines? Well, hopefully you were able to determine that the slopes are the same. Okay, and that's the big thing that we're talking about here. Okay? Parallel lines have the same. So for example 1, it says write an equation of a line in slope-intercept form. So remember that's y equals mx plus b for the line that passes through the given point and is parallel to the graph given of the given line in slope-intercept form. So basically, the only part that's confusing for students is that they don't know what to do with this, okay? The directions tell you that it's just going to be parallel to that line. So I just want to find the slope of that. Well, the slope of that is 3, which means my parallel slope would be 3. Now, that seems redundant right now, like you don't step, and it's fine if you don't ever write it, but it will help in the future. So now we're back to where we always we have a point, we have a slope, so we can plug it into a form. So y minus our y1 equals m times x minus our x1, right? Remember, minus negative becomes plus. That's why it's plus 4. Big thing is we want slope-intercept form, so we're going to solve for y. Distribute 3x minus 3. And then all we have to do is subtract 4. Y equals 3x minus 7. Now, yes, it's very similar to this one, right? But that's not always the case, so don't think that there's a pattern there. All right, for the next one, I need to find the slope of this line. So that means I do need to solve for y first because I don't know what it is by looking at this graph. So, or that equation. So we would move 2x to the other side by subtracting it, and then we would divide every single thing by 3. So y equals 2 minus 2/3 x. That means that my slope is negative 2/3. Don't be confused because the y-intercept is listed first. So that means my parallel slope would be negative 2/3. Okay, so now we have slope and we have point. So we're going to plug it into point slope form. So y minus our y1 equals slope times x minus our x. Now again, we need slope-intercept form as our final answer, so we need to distribute. Y minus 6 equals negative 2/3 x minus 4/3. And you could just have it as 1 1/3 or 1.3 repeating, whatever you would like. Then we add 6. So y equals negative 2/3 x, and this would give me minus 1 1/3, 4 2/3, or 4.6. Okay, I'm okay with your y-intercept being a fraction of any sort or decimal. The thing is, just like we always talk about, this slope needs to be a fraction, okay, only.